How do we graph tangent and cotangent? Well, as a reminder, the way that we're going to graph tangent is we'll have our asymptotes at pi over 2 and negative pi over 2, and then we'll have a nice smooth curve hitting equilibrium at the origin and ascending. For cotangent, we have our asymptotes at the y-axis and then at pi, and instead of being an ascending function, it's descending. Of course, this is assuming that it hasn't been reflected in some way. So to graph sine and cosine, we recall that we're identifying the amplitude, period, horizontal, vertical shift, drawing an equilibrium line, graphing a point at our horizontal shift. However, this is going to change substantially when we're starting to do tangent and cotangent. So the period, for one thing, changes. Instead of calculating it as 2 pi over b, now the period is pi over b. Everything else for amplitude, horizontal, vertical shift stays the same. We draw an equilibrium line graph at x equals negative c over b. Tangent starts at equilibrium, so wherever negative c over p is. We move a half a period left and right and graph our asymptotes, and then graph ascending inflection points. Those inflection points will be based off of the amplitudes from the equilibrium line. For cotangent, we start at an asymptote, we move a period right and graph a second asymptote. And then between the asymptotes, we graph an equilibrium and graph descending inflection points. So these look very similar, but here, wherever our negative c over b was, is going to be our first asymptote, whereas with tangent, our negative c over b is our first equilibrium point. So let's do some examples. A is 2. Our period is pi divided by our b, so 2. There is no horizontal shift, and the vertical shift is 1. So let's draw an equilibrium line. We have no horizontal shift, so we'll start here. Because it's tangent, we start as an equilibrium point. Now, we can take this pi over 2, and that is how far we would get to the next equilibrium point. But what the instructions say is to move half a period left and right and graph the asymptotes there. So let's do that. Move half a period left, which is pi over 4. Half a period right. Negative pi over 4 and pi over 4. And those are our asymptotes. We can keep going more periods and we'll see where the asymptotes are. So here are our asymptotes. Because this is tangent, our graph is going to be ascending unless we have negative a or b terms. And our amplitude is 2, so when we go halfway to the right here, we'll go up 2. And when we go halfway to the left here, we'll go down 2. So those are our ascending inflection points. Inflection point, inflection point. Inflection just means the slope is changing from increasing to decreasing. Now the slope is still positive throughout, but the slope is changing its change in some sense. If you want to be very careful, you're going to draw these arrows at the end of your tangent lines. So this is a graph of y equals 1 plus 2 tangent of 2 theta. Another one. The amplitude equals 3. The period is pi divided by b, so 2 pi. h is 0 and k is -1. So let's draw a horizontal line at -1. Because this is cotangent, we start at an asymptote. So our horizontal shift tells me an asymptote is there. We can move right a period, move a period right, and that will give us our next asymptote. So from 0, we move right to 2 pi. That will be our next asymptote. Halfway between is our equilibrium point. And then we're going to draw descending inflection points. Because of this amplitude of 3, we know we're going down 3. I'm moving to 3 pi over 2 because that's halfway between the equilibrium point and the asymptote. Halfway between this equilibrium point and this asymptote is over here. And I want it to be descending, which is why I'm doing this. Now you shouldn't draw a line here. It's hard to do this really cleanly. Over here, this will look like that, approximately. 1 period right of pi is 3 pi. 1 period right of pi over 2 is 2.5 pi. So this is what that curve looks like.